Hello and welcome to the lecture on data and data management, in which we set the context for most of the rest of the course. In this brief lecture, we will remind you of the importance of data for the successful organizations and discuss some of the issues involved in the management of data. More specifically, at the end of this lecture, you will be able to describe the importance of data for organizational success and the challenges involved in successfully managing data, define the terms data, information, database, and database management system, and discuss how database management systems help alleviate some of the issues involved in data management. Let's start by reminding you of some basic definitions, most of which we already covered in ISM 3011. Data can be defined as raw facts. For example, the fact that I'm male is a simple piece of data. Information arises when data is organized in a meaningful manner. For example, once you have accumulated a series of facts about individual faculty members, such as their genders, their ages, and the universities where they received their degrees, you can now organize this data so that all the facts about a specific faculty member are somehow stored and presented together. You may even want to go further and analyze the data more deeply, for example, to determine the gender ratio between faculty members in a university. A database provides a way to store the data in an ordered and organized manner so that logically related data, such as all the facts that you have gathered about each faculty member, is stored together. Databases are typically designed to be shared by many users. A database management system, or DBMS, finally, is a piece of software that stores the data in an organized manner and, among other things, controls access or updates to the data. We will discuss the various functions of a DBMS in more detail later in this section. It is also useful to introduce some basic terminology related specifically to DBMS. The data repository is the storage where the physical or actual data is kept. A data dictionary describes the data in the database. The content of the data dictionary are so-called metadata, data about data. A very simple example of a piece of metadata is the description of the type of some piece of data, such as the fact that age is an integer. With this new terminology in mind, we can now redefine a DBMS as a software application that manages the use of the data repository and of the data dictionary. There are a large number of DBMS vendors, the most important of which are Oracle, IBM and DB2, Microsoft SQL Server, Sybase, Informix, and NCR's Teradata. Data are of course crucial for organizational success. An organization, no matter how simple or complicated, needs to have access to data, both to run its current operations and to plan for the future. While the actual details of the data will differ between organizations, most organizations will need data about their products, their customers, their employers, their operations and operational assets, and so on. As an exercise for yourself, you may want to think about what data a university would need to collect and store. Since data is crucial to organizational success, organizations must manage their data carefully, and data management is difficult. There are several reasons that data management is hard. For example, organizations are collecting more and more data. For example, in addition to the data about their customers, products, employers, and so on, that organizations already collect, many organizations now have a web presence and a social media presence, and they will want to collect data on the traffic that is attracted to these sites. Who came to our site? How long did they stay? What pages did they look at? And this is only the beginning. You will have heard about the Internet of Things, in which all types of things are fitted with sensors that collect data and stream this data over the Internet for organizations to collect, store, and analyze. Also, As organizations become more aware of the importance of data, individuals associated with the organization, whether they be customers or employers, will need access to that data. For example, while it's obvious that people in a company's warehouse will need to have information about inventory levels as you start selling products over the internet, you may also want to share at least some of this information with customers so that they know how long it will take for an order to be fulfilled. Moreover, as you share data with parties that hitherto did not necessarily have access to your data, you want to make sure that you share this data in a controlled manner. For example, internet customers do need limited access to the inventory database. For example, they should be able to determine whether a particular product is in stock, but they should not be able to determine whether you sourced the product, where you sourced the product from, and how much you paid for it. And of course, as more people have access to the data, the issue of security looms large, as does the related issue of privacy. An online bank needs to make sure that the financial information it has about its customers is secure, and that no unauthorized user can access it, and that it protects the privacy of its customers. As an aside, an emergent concept in the field of databases and data analytics is data ethics. How do you ethically collect, store, and share data? There are also some technical issues you will need to address. For example, since data is crucial to ongoing operations, you want to make sure that you have a backup of the data and that you can quickly recover when something goes wrong. Later in the course, we will address the issues of backup and recovery and the difficulties involved in all this in more detail. The final issue that I would like to mention is the need to eliminate redundancy. The issue is essentially that if you store the same information more than once in a system and it needs to be updated, you need to make sure that it's updated everywhere it is stored. For example, many employers at USF St. Pete are also students, and if I store their address in an employer database and in a student database, and they tell me that they've moved, I need to make sure that I update the record in both databases. If I do not, my data will be inconsistent. In order to avoid this, it's better to make sure that I need to store the address only once. As we shall see as we progress through the course, the issues involved in data management are considerably easier to manage if you use a DBMS. There are four primary concerns in managing data, namely data accuracy, data organization, data security, and data access. Let's discuss each of them in more detail. Data accuracy is obviously about making sure that the data stored in the database is accurate and correct. Inaccuracies may occur for two reasons. First, data may be entered incorrectly, for example because of human error, or if you use an automated data source such as a sensor, because of problems with the automated data source. For example, a thermometer that does not read the temperature accurately will lead to inaccurate data. Second, data may become inaccurate if you use buggy software to update the data. For example, if you want to automatically calculate an interest rate for a customer based on their credit score, but you implement the formula that the bank wants to use incorrectly, you will record inaccurate interest rates for the customers. Obviously, an organization can and should put several safeguards in place. For example, when data is collected from an automated data source, you should periodically check the accuracy of the data produced by the sensor. And when you use an automated procedure to update data, you should make sure that the program is thoroughly tested before you start using it. As far as avoiding human error is concerned, you can try to catch some errors automatically. For example, if an operator is asked to enter an age for an internet customer, the range should probably be between 18 and say 120. Another technique that is sometimes used, especially when a large amount of data is to be entered by human operators, is to ask several different operators to enter the same data. If all agree on a particular record, it's probably accurate. If they do not, you know that at least one of them has made an error. second issue for data management is data organization. In general, you want to make sure that the data is organized in such a way that that makes it easier to manage space requirements. For example, if you have a database with millions of records, such as a census database, it probably makes sense to use a code to store the gender of an individual rather than type out the full gender of each individual. As mentioned of the previous slide, if you organize the data correctly, you can also enforce some data entry rules. Often this can be achieved by using a particular data type for a piece of data you want to store. Thus, if you make sure that age is declared as an integer, it will not be possible to enter foo as a valid age. A further consideration is to organize this data in such a way that data can be retrieved more easily and faster. Often this is achieved through indexing. Thus, if we know that we are most likely to retrieve data from a customer database based on customer number, we can create an index for this attribute, thus making retrieval faster. We will discuss indexing in more detail later in the course. Finally, as again mentioned before, you want to, as much as possible, avoid data redundancies by making sure that each fact is stored only once. Apart from the fact that this minimizes storage requirements, it also helps you maintain data integrity. Recall the example that we discussed before of the USF St. Pete employee also being a student and potentially having their address stored twice. The main concern of data security is obviously to make sure that the data is safe. There are two aspects of data security, namely access security and physical security. Access security essentially involves making sure that users and applications only have access to the data they are authorized to access. We can use different so-called authentication methods to make sure that users or applications can only access data they are entitled to access. The most commonly used form of authentication are usernames and passwords. But if you use a smartphone, you will know that it's also possible to authenticate users through some biometrical options, such as fingerprints, or in the newest iPhone, your face. Once a user or application has been authenticated, you can control what data users or applications can access or manipulate by setting certain permissions. Physical security involves protecting data against physical corruption or loss. For example, you can physically secure the building in which the database server is housed through physical locks. You can also use fault-tolerant hard drives, also called RAID, redundant array of independent disks, and configuration of hard drives, which allow you to fully recover the data if one of the drives crashes. Another method to physically protect the data is to make sure you duplicate the data to a different site, often called mirroring the data. The final concern in data management is data access, and it is closely related to the issue of access security. It involves controlling who or what accesses to which data and how. Access to the data can either be direct or indirect. Direct access is typically achieved through queries, typically written in SQL, structured query language. SQL is a standard language for accessing databases, and although there are small differences between different DBMS vendors, most SQL queries will work in every DBMS. Thus, if you learn how to write SQL queries in Oracle, you also know how to write SQL queries in Informix or SQL Server. Indirect access involves accessing data through an application. An example is the use of a web interface to access an inventory database of some online vendor. Typically, an application generates a SQL query to retrieve the data from the underlying database and then displays this to the user. Queries can be used to perform all possible database operations. In particular, queries can be used to retrieve data, insert data, or manipulate existing data. Moreover, As we said, we can use user roles and logins to restrict access and to restrict what type of queries in the user or application can perform. As we progress through the course, you will see multiple examples of this. Finally, as we said multiple times before, the data management tasks is made considerably easier if you use a DBMS. Any DBMS will contain a database engine and a query processor. The database engine is the heart of the DBS, and it coordinates the tasks performed by all other DBMS components, including tracking where data is located, how it is accessed and updated, and it is responsible for the main issues that we identified above, namely data accuracy, data organization, data security, and data access. The query processor handles the parsing, optimization, and processing of queries. In addition, many DBMSs also contain a form generator, which creates screen layouts or forms for data input or display from or to users, and a report writer, which generates reports based on queries for displaying or printing. And this completes this brief lecture.